Hi, welcome to everyone. Today we are going to start another important session on computer networks, which is IPv4 and IPv6. So, in the previous sessions, we discussing about the different kind of voice layer protocols, as well as we discussed about this TCP/IP protocols, which is transmission control protocol and internet protocols. So, today's session we are going to discussing about the important topic of this IPv4 and IPv6, which means internet protocol version 4 as well as version 6. So while we're discussing about this TCP/IP internet layer, so there we're focusing about this TCP layer as well as which emerge in this IP protocol values only. While we using this TCP layer, while we designing this a transmission control protocol, how it will be helpful to develop this one with the help of this internet protocol that we discussed in the previous sessions. So based upon the previous sessions, we are going to analyzing about what is IPv4 packet and what is IPv6. So in that one, how we are able to emerge this IPv4 and what is the updates on this IPv6 and where we are using this IPv4 and what is the difference between both of the IPv4 version 4 as well as version 6. So today we are going to discuss all these parameters. So first thing is what is meant by IP, which means what is meant by this internet protocol. So the IP is stands for we calling as a internet protocol. But what is meant by this internet protocol? So when you see this one, every system, every internet we having as a separate kind of address. We calling as a IP address. For example, every system will go for this any kind of LAN connections or a single router connections or single internet connections. Every system we having a separate kind of IP address only. With the help of this IP address only, we can able to usage of the respective internet versions. So here the IP stands for the respective internet protocol. So which we having as a one particular address that is assigned to each and every device. Assume that one, for example, we having as we design this a one kind of network, which means we design this one kind of a LAN communication that is helpful for developing a Wi-Fi communication services. So in this Wi-Fi, n number of routers are there, n number of devices are there. So every device we having as a particular IP address is there. So for example, in the router we having as a fixed address is there. But after this router, the splitting the router into n number of devices, we are getting separate kind of address is there that we calling as a IP address. So each and every devices we connect to the network in the same network that must be assigned a single or individual IP address values only. So in this IP address, so that address is used for our communication, which means we can able to browse internet communications or we can able to share the information or SMS or MMS. What are the things we are using that one? With the help of this IP address, first we establish the IP address, then only we can able to accommodate to communicate the signal to another resources, another transmitter or another client services. So it behaves as an identifier. With this address is used to identify the device on a network. For example, so every system or every individual we having a separate kind of address is there. That address is denotes the respective identity of the things. Maybe a person identity or maybe things or else any kind of machines. So here what are the address we are using, what are the IP address we are able to use that one, that address is identify the respective address that device on the network. So what are the networks, what are the applications or what are the devices, what are the PDAs is available in the same network that having as a one kind of IP address. With the help of this IP address only we can able to communicate to the another resources. So precisely we calling as a packets. So when discussing about this previous session, when discussing about this transport layer or network layer or else data link layer, we discussing about this frame kind of structures or else we discussing about this packet kind of structures. So here similarly here also the technical format of this IP address, which means that should be how much amount of data packets we received or else how much amount of packets should be transmitted, that should be in the form of this, in the form of packet only. Where go for this data link layer or else in the down the layer we discussing about this frame kind of structure, but in the network layer and above the layers we discuss in the form of this packet kind of structure, which means what are the data we received and what are the data we transmitted, which means the encode kind of information or the decoding kind of information, all the things forming in the form of this packet structure only. That is the reason the technical format of IP address which we calling as a packet. So precisely saying that one, how many packets are received, which means how much amount of information we transmitted or else how much amount of information we received, we measured in the form of these packets. So when go for this both network, we'll go for this IP network, which means internet protocol or else the transmission control protocol, they are combined together and they forming as a TCP/IP layer. They forming as a TCP/IP reference model. And So here another important thing, we'll go for this, when we create any kind of virtual connections between the source and destination, this TCP IP is a plays a vital role to create a virtual connections. While we see this discussing about previous sessions, we're discussing about circuit switching or we're discussing about packet switching. So they were discussing about connection oriented communication or a connectionless communication, which means we discussed about the virtual internet communication, the virtual connections, because nowadays the world will grow up in the virtual connections more only. We able to do the simulations, we go for this any kind of things, we are operating in the virtual manner only. So while discussing about this TCP segmentation or TCP packet formation, the information the information transmit in the virtual manner only. That is the connection between source and destination. And we can also define this IP because when taken as any kind of IP address, that should form this numeric values only. So based upon the bit address, for example, we having as a two things are there. When you go for this V4 version or this V6 version, based upon the version, the thing should be in the form of this a numeric address. Like we having as a 192.255.255.255. That kind of numeric address we have that one, because this address is represented the based upon the region, based upon the nation wise, region wise, local wise, as well as respective system wise. So that kind of information we grab that one, that should be in the form of this a numeric address assigned only. For each and every device we assign the respective IP address values only, and each and every address is different to the other address, even though the same network, they forming a same network. In the network n number of device we connected, the same router we connected n number of routers, but even though IP address is different, the LAN connection which you given that one, this should be changes, which should be 01 or 02 or 19 or whatever, etc, etc. That should be different to other system or one to many systems. So here each and every address is assigned to each device. That device network may be identified uniquely, because based upon the version, based upon the values of this one, we are going to assign, we are going to analyzing about which state this one. For example, we write a one name. For example, our college address is like MLR Institute of Technology, Hyderabad, India. We write like this only. At the same time, we are mentioning the respective pin code. So based upon the pin code, we assign which country or which state or else which state, like which town or which city, and what is a particular region, what is a particular locality we identified based upon this pin code. Similar manner, same way, when you go for this respective address value, we are able to identify that should be comes to which nation, which region, which locality, and which area. All these things will be based upon that one. At the same time, these values we mentioned that one, that should be comes to which device also. We can be precisely can be able to identify that one, because every system having a unique IP address values, we have that one. And so that facilities based upon this routing algorithm or based upon this routing of packet values only. So here the TCP protocol, which is based upon this a 32-bit logical address, that should be calling as a IPV4. For example, when you go for this version 4, we having as a 32-bit logical address, but when you go for this IPv6, it should be comes to the hexadecimal value soon, because the version to version changes, we have to increase the number of usages as well as number of customers and number of clients based upon this logical address also variable. So that is the reason we calling as IPv4 version 4 or as version 6. Version 4 comes to this 32-bit logical address, version 6 comes to this hexadecimal kind of structure. So here this IP address consists of two parts. First one is considered network address and another one is host address. In the IP address, what we having as IP address, that we in the form of this two sections. One is we having as a network address value, which means part of network service we are using that one, and next one what kind of host address we are using that one. Within the creation network, any hosts are there and how many hosts presence in the network, all these details we having here in the section. So these are two types of addresses are there. One is version 4 and the one is version 6. So what is meant by this version 4 and what is meant by this version 6? So IPv4 is a connectionless protocol. As we discussed this one, this should be comes to this a virtual network. This should be comes to heading as a virtual network. In the virtual network, that should be a connectionless protocol which comes to this packet switching network such as Ethernet. As we discussed in previous session, discussing about these two things. One is a circuit switching mechanism as well as a packet switching mechanism. So in this one, the virtual mechanism we are using that one. What is virtual mechanism? Apparently we calling as a connectionless protocol. So without a connection we are using that one. So that is the packet switching network. How we are using that one? With help of this Ethernet, that we calling as a wireless communication, a connectionless protocol or as virtual protocol. We are using that one, and here it will be operate in the best effort in delivery model. How can we say best effort? Based upon throughput analysis, based upon accuracy, based upon the granularity which we are using that one, we can able to say this we having as a best effort delivery model. So neither delivery is guaranteed nor the proper sequencing, but it has to avoid the duplicate delivery is assured. So that is a major issues. We have to avoid the duplicate delivery. And this Internet Protocol version 4 is widely used in protocol, but where I'm using this protocol, when you go for this LAN communications or different small range of communication, different kind of network kind of communications, we are going to using this IPv4 communication. At the same time, it has to provide the logical connection between network devices by providing the identifier for each devices, because as we discussed, each and every device, the IP address having a network address, we have that one, as well as we having as a host address. So based upon the network address perspective as well as the host address perspective, so this has to provide a different kind of logical connection. We having as a logical address, we have that one. So based upon the logical address, we can able to identify that device comes to which model or which PDA. We can able to analyze that one. And so when you see this one, this is the datagram packet. So what is with this datagram format, or as in the form of this packet structure? So what is with this version 4? When you see this version 4, we having two things are there. One is header values as well as respective data. Apparently, we having some kind of information. But in the header section, we having as a length should be 2260 bytes. It's not a bit, it's a byte. 2260 byte. So in this one, we having as n number of sections are there. So what is section we having? We having respect to a version, which we having as a version, whether it's a 4th version or 6th version. We are using IPv for version 4. We taken about this version, which is a 4-bit range values only, and the header length value, which consists of a HLEN, which means header length, it is also having as a 4-bit value. And if any services are required, we taken about this 8 bits, and the total length should be 16 bits. So entire 20 to 60 bytes we segregate into version value. The version length is 4 bits, header length is 4 bits, service required for 8 bits, and total length should be 16 bits. And in this one, in this version and header length, we again segmentation to identification, the 3 flags and respective fragmentation value. So here the fragmentation mechanism in the sense, for example, we having a use packet is there. We are segregating or we segmentation this packet into n number of frames. That kind of fragmentation we have here. And we having as a time to live values, which means 8-bit services we are using that one. And we having as a protocol. So what kind of internet protocol we are using that one to transmit the information, to communicate the resources. And here we having as a header checksum, which we having as a 16 bits, and we having a source address, and we also having as a destination address, and we having as optional for future perspective any kind of checksum mechanism or any kind of operational perspective, we put as a optional mode that we give some kind of length value, which we give as a 32-bit length. All these are, when we go for the source address value or we go for this destination address value, these are a 32-bit values only. And what kind of service types we offer? So the TCP/IP or as the IPv4 version 4, they having a different kind of service types are there. Like we go for this the precedence, like which means we go for precedence value, or else we go for this minimized delay value, we go for the maximized throughput value, and we go for this maximized reliability, and we having as a minimized cost value. All these things we calling as a TOS bits, which we calling as a service offer, a types of service offer, the things which we develop in the IPv4. And this TOS bits is a 4-bit subfield value. When you see this one, which you mentioned this 4-bit, we having as a 0000 bit 1, 2, 3 as well as 4, which means 4 and 8. It's a 4-bit device. So all 4s are there, which means this value should be all 4. There should be normal value of any one is there, that based upon the this value there should minimize delay, or else maximize reliability, or else maximize throughput, or else maximize delay. So based upon this value, based upon the, for example, here I'm having as a DTRC value is there. We having as a 4-bit information is there. That should be 00 we have, 001 we have, or else 0010, 0100, or else 10. This kind of data table we form that one. So in this table, when you see this one, this table, when apparently we are using this toss bits value, so that is all the zeros are there, we're calling as a normal bit value. It's a default section value. If any one is there, 0001 is there, we calling as the cost value, because this C should be indicates the minimize the cost value. And similarly, if changes to 10, that should be R is which changes, that is maximize reliability. Similarly, maximize throughput. Similarly, the minimize the delay value. And when you see this one, we mentioned this flags we are using that one. But what are the types of flag we are using that one? That is do not fragment or else more fragment. In some scenarios, we don't require the fragmentation. We're getting a small kind of piece of information we have that one. So no need to go for this fragmentation, because fragmentation also required much more time taken process. The delay should be increases. So no need to go for this fragmentation. But when you get this huge amount of information, we transmit that one or else we receive that one, definitely we go for this fragmentation mechanism. We go for this decoding process as well as encoding process. So based upon the D and M, which is do not fragment or else the more fragment mechanism which we are using that one. And we see similarly we go for this IPv6 version. In the previously IPv4, we having as a 32-bit values only. We having as a 32-bit range values only. But they having as a value should be all the things are in the form of this a numeric range values only. But when we entering into this IPv6, that IPv6 is developed by the a task force, which is the Internet Engineering Task Force, that deals with the problem of this IPv4. What is the IPv4 problem we are facing that one? IPv4 we having as a limited kind of structure behind that one. We can able to accommodate to a limited members. Where you go for this using this LAN connections or MAN connections, we are able to accommodate based upon the duration, based upon the bandwidth which we have in that one, the limitations we have that one. So that kind of problems we are able to overcome that one. We developed another version which we calling as the IPv6. So what is the IPv6 advantages? That we having as the 128-bit addresses. In the previously IPv4 we having as a 32-bit range only. But while we jump into this IPv6, we can able to develop up to 128-bit IP address value, and that address space should be which is 2 power 128. This should be a huge amount of information, a huge amount of channels we can able to accommodate this in this scenario. So that is the reason this is a much more bigger than this IPv4. And in this IPv6 we are using this hexadecimal values. We can able to accommodate the hexa representation we calling as a hexadecimal, and this we having as 8 groups. 1, 2, 3, 4, 5, 6, 7 and 8. We having as 8 groups, and each group we represented 2 bytes of information. We'll see this one. In IPv4 we enter length is 16 bytes, we have that one. But what is the information we can able to accommodate 128 bits values only. So that is the reason this forming as a hexadecimal range value, and this having as 8 groups, and each group contains 2 bytes. 8 into 6, 8 into 2, 16 bytes information we have that one. And this also similar to the IPv4 version, but here the length should be increased. Then we're getting away 20 bytes maximum here, 60 byte, but here we are using 40 bytes of this base header value, and the payload information we having as a 65535 kind of range information we are using that one. That should be extension header. That should be an optional value, but should be extension headers of there. And the data packet, what is information getting from lower layer to upper layer, all the things we can able to accommodate in the payload section. And when you see this one in the IP datagram format, when you see in the previous one, this one, there also we are using the version and the header length value we are using that one. But here we are able to accommodate the precedence value and the flow label value we are using that one. So here we measure the what is the payload length value. Based upon the payload length value, we can able to accommodate to the next header value as well as the hop limit value. Similarly, we are able to accommodate the source address as well as destination address value. So this next address is accommodated to next address of the next frame value or next fragmentation value or packet value. That should be mentioned the header length value. All these things comes to the picture of this information values only. So, but what is the advantage of this IPv6? IPv6, we as you mentioned that we having as a 128 byte bit range. So we having as a large address space. We have that one. We having as a large amount of address space and it will accommodate that one. And we having as a better header format. And here the allowances for extension, if we go for this a new option and we go for this allowances for extension, we have that one. And is support for this resource allocation and it having as a more secure manner, but because when we go for your using hexadecimal manner, that should be very secure manner we are using that one. And when you go for this, when we assign this 128 bit range compared to this 32 bit range, we can able to accommodate the n number of persons, we can able to accommodate easily, because the header length should be very higher the value. So, but what is the comparison between IPv4 and IPv6? So IPv4, the majorly we having a 32 bit range, but IPv6 we having as a 128 bit range. Here we having as a respective a numeric mechanism. Here we having as a numeric, as well as we having as a hexadecimal value. We having as a hexadecimal value. And here you can able to accommodate 2 per 32 address range value, but here you can able to accommodate 2 per 128 accommodate range value. And here we having as a limited kind of optional services, we are using that one because of limitation of this bit range value. But here where we go for this, the bit range increases, we are go for this optional value, we are go for this much more optional value, we have that one. That is major advantage of this IPv4 as well as IPv6. And as well as the information transmission space, or as the bandwidth, or as the throughput analysis, all the things are much more higher in IPv6 range compared to this IPv4. That is a major advantage of, or as the major concerns between 30 bit range or as 120 bit range, which is version 4 value as well as version 6 value. Right. So while I conclude this session, in this session we are discussed about the importance of this IPv4 and IPv6, which we discussed about what is meant by this IPv4 and how many range we have that one, what is the address spaces we have that one for IP version 4, as well as what kind of data frame format which we have that one, that we discuss in IPv4. And same we discussing about IPv6. At the same time, we much more discussing about why IP version 6 is important than version 4, that we discuss in this session. In the next session we discussing about this, a simple revision of the topic. So as we discuss about revision kind of thing, so basically we're discussing about this transport layer services. So in the transport layer, so what are the services we offered in the transport layer to the network layer, or else in the upper layer, which we having as a session layer or presentation layer, what are the layers we are present in this above the layer in the OS reference model, and same thing what is present in this TCP/IP reference model as well. And the another important thing here we're discussing about what kind of algorithms, which means what kind of routing algorithms which we are using. That is also very important topic, because when we discussing about routing algorithm, we have n number of things are there. We go for this a distance vector routing algorithm, which comes to this RIP protocol, a routing information protocol, or else we discussing about this OSPF protocol, or else we discussing about this a Bellman food algorithm, or else a Dijkstra kind of algorithms. All these things we discuss comes to the routing algorithm, which means basically what kind of routing table which we represented the based upon this kind of information, we grab that one and we preparing as one kind of table we calling as routing table, that we discussed in the previous sessions. As well as we also focusing about this what is internet protocol versions, which means we having as a number of versions are there. We go for this IPv4 version 4 or as version 6. These are the important topics which is discussed in the previous sessions. Thank you.